Hey guys, welcome back. Pre-Calc Lesson 12.2, Finding Limits from a Graph. So, what is the limit? The limit of a function is simply the y value of a function as x approaches a number. So remember that when these get really complicated and you're asked to find a limit, it's just the y value of a function. Now the notation we use for a limit, LIM, shorthand for limit, f of x is our function notation, x approaches c. So what we say here is the limit of f of x as x approaches c. Okay, so let's take a look at three types of limits. The first one right here, the limit of f of x as x approaches 2 minus. Well, we don't really say 2 minus. It's not a negative 2. What that is a direction. This right here tells us that we're approaching from the left. So on my number line here, if I want to approach 2 from the left, that means I'm coming from negative infinity, I'm going to approach 2. So it's going to look like that. We happen to call this a left hand limit. And we say that x approaches 2 from the left. Now I'm going to abbreviate this. You'll see me abbreviate this occasionally as LHL for left-hand limit. The calculus teachers aren't super fond of that, so don't tell me you learned it from me. Okay, next one. Limit of f of x as x approaches 2 plus. Well, again, that's not really 2 plus. That is a direction. So you can probably imagine from the one up above that that's going to mean from the right. So now what we're doing is we're approaching from the right, and we're going to stop when we get to 2. We're going to look at what we're pointing at. So you can probably figure it out. This is called a right hand limit. I'll abbreviate RHL. And the way we say that is x approaches 2 from the right. Okay, last one. So this one right here, you notice limit of f of x as x approaches 2. Like, oh, hey, there's no right or left on this. Well, the reason there's no right or left is because you're think of it as bringing your two fingers together at the same time from the left and the right. Okay, so what we're doing here is we're actually approaching from both directions. We're going to see what we're pointing at. Okay, so this isn't called a right or a left. This is just called the limit. So when we just say find the limit, you're finding what both arrows are pointing at. Okay, now there's something you need to know here. If the left-hand limit does not equal the right-hand limit, so they're pointing at different things. All right, so visually it's going to kind of look like this, pointing at different things. What we say then is the limit does not exist. However, if the left-hand limit equals the right-hand limit, then the limit equals whatever number or value you're pointing at. Okay, let's take a look at a graph. Okay, so I want to use this graph here to find the limits below. So the first one, the limit of f of x as x approaches negative 6 from the left. So we got to make sure we know what that means. When I see that, that means from the left. Okay, now I'm going to erase that because I don't want this to get really cluttered. You can see there's a lot of writing here. So visually, here's what we're doing. You follow the graph until we get to negative 6, and we're coming from the left. So I'm doing this. And then when I get here, I look at the y value that that's pointing to. So that would be a negative 3. Well, that just means that my limit of f of x as x approaches negative 6 from the left is negative 3, because that's what I'm pointing to when I approach from the left. Now, if you notice the next one, let me get rid of that. If you notice the next one, very similar, except now I'm approaching from the right. So you follow the graph until you get to negative 6. So I'm doing this, not to negative 6 yet, not to negative 6. Well, there's where I'm getting to negative 6. Well, what's that y value? Well, that y value also happens to be negative 6. So now let's put those together, because in the next example, you notice here, there is no right or left. It just wants the limit. So here's what we do. You take your left-hand limit and your right-hand limit, and you see if you're pointing to the same number. Well, notice these two are not the same. So since those are not the same, the limit does not exist, because the left and the right would have to be the same in order for you to be pointing to the same number from both directions. All right, let's try a couple more. So this one here, we're going to approach negative 1 from the left. So, all right, approaching negative 1. Nope, not there yet. Coming down here, approaching negative 1 from the left. Now, I don't care if this is an open circle or a closed circle. It's what you're pointing to. So I'm pointing to negative 6, which means that limit is negative 6. Okay, so my next one. The limit as x approaches 1 from the right. So approaches negative 1, approaching negative 1, right there. That is my limit. That's going to be 4. Okay, so now I just have the limit as x approaches negative 1. So you have to think about what both are pointing at. Are these two pointing at the same number? Well, no, they're not. One's a negative 6 and one is a 4. So again, the limit does not exist. The limit is what both are pointing at. And if it's a different number, it just does not exist. Okay, last one. X approaches 2 from the left. So, okay, coming from the left until you get to 2, you just keep going, oh, right there. So that would be a 1. Okay, so now what we're doing is now we're approaching 2 from the right. Come from the right until you get to 2. Well, that's also a 1. So now you just want to find the limit. Well, the limit is both the left and the right. And you can see they're pointing to the same number. Yeah, because they're both equal to 1. The left hand and the right hand are both equal to 1. So the limit now is just equal to 1. Okay, what we're going to do next is we're going to find limits numerically on a graphing calculator. So we're not going to be using the graph itself, but rather the table. So first thing we need to do is we need to create a table. All right, and we do that by getting 7 values surrounding C, whatever that constant is. So if I have to find the limit as x approaches 2, I'm going to have 3 values less than 2, 3 values more than 2. Interpreting the limit from the table. So this is going to be the new part here. We're going to have to use, I can't show you this unfortunately on this, but I don't have a calculator emulator. What you're going to do is you're going to set up your table so that you can manually input the independent variable. So the way you're going to do that is you're going to hit your second key, second function, and then window, because really you're not using the window. What is up above it is the table set. And then you're going to see in the menu, I don't know what number it is, but you're going to see, I think it's like the 4th thing, independent, and you want to set that to ask. I believe it's defaulted to auto. And you're going to do that, and then when you go to your table, it's just going to be blank. And you're going to be able to put in any number you want for your x value. So your table is going to kind of look like this. Your value for C is going to be in the middle. And then what you're going to do to get the three values on either side because we want to approach C. So we want to get closer and closer and closer to it. So here you're going to subtract 1,000th from C. Then we'll subtract 100th, and then we'll subtract 1/10. Going the other direction, whatever C is, we'll add 1,000th, then we'll add 100th, and then we'll add 1/10. And we're going to use this to determine the limit, because a lot of times it's not going to exist at C. So this is kind of representing our left-hand limit, and this would be representing our right-hand limit. If those two values are going to be the same, then the limit exists. And then we're just going to verify it by graph. All right, but a lot of times, again, using the graphing calculator to do this, it's kind of tricky. All right, let's practice. And again, I apologize, I can't show you guys this on the calculator, but basically what we're going to do first is take this right here and put it into Y1. Okay? So if you do that, and you go through that menu we talked about right here, and you set your table up so it's going to allow you to input your X values. Well, I like to set this up on paper before I go right to the calculator. So here, since I'm finding the limit of f of x as x approaches -2, that means -2's got to go in the middle of my table. Now, with the negative numbers, it gets a little tricky because remember, what I'm going to do here is I'm going to subtract 1,000th. All right, so that's actually going to give me -2.001. This will be -2.01 because then you subtract 100th, and this will be -2.1. Okay, so going this direction, I'm going to add 1,000th. So this is going to be -1.999, then 100th, so -1.99, and then 1/10, -1.9. So like I said, that's where it gets a little confusing. These numbers have to be numerical order from the least up top to the greatest here, while that one is in the middle. All right, so if you put all this into your calculator, in your table, I'm just going to jot down what my calculator says. I got -4.1 here, -4.01 here, -4.001. This was an error, did not exist. Then I had -3.999, -3.99, and -3.9. Okay, so like we talked about up above, notice these numbers here. They're pointing, they're approaching. This is our left-hand limit. They're approaching, it looks like, -4. They're getting closer and closer and closer to -4. We're going this direction to my right-hand limit. And if you follow those numbers, those are also getting closer and closer and closer to -4. So since both of these are pointing towards the same number, even though it doesn't exist here, that doesn't matter. If they point to the same number, then that is your limit. So the limit here is -4, and this is the answer to the question. The chart is not the answer to the question. The left-hand limit's not the answer. The right-hand limit's not the answer. The limit is the answer, and in this case, it's going to be -4. So what's this graph look like? All right, well, this graph, let me move this over a little bit, basically looks like this. It looks like a line. If you throw it into your calculator and hit graph, you're not going to really notice what's happening here. But there's a hole in the graph. So it kind of looks like this. Because the function does not exist when x is -2. Now, if you want the exact coordinates of that hole, it's easy. X is -2, and y is -4, because remember, limit's the y value. So the coordinates right here are -2, -4. Okay, let's try another one. All right, so I've got f of x equals x over x minus 1, and your instructions are to find the limit of f of x as x approaches 1. So to set up my chart, 1 has got to go in the middle. Okay, well then going backwards, I'm going to subtract 1,000th. So this is going to be 0.999, then 100th, so 0.99, and then 1/10, 0.9. I'm going to add 1,000th, 1.001, add 100th, 1.01, add 1/10. Okay, so if I throw that into the table, what I got here, let me just double check, is negative 9, negative 99, negative 999. Does not exist at 1. Then I had 1001, 101, and an 11. So notice this, all right? These are not approaching the same number. What are these getting closer and closer to? Well, they just keep decreasing and more quickly. So that happens to be my left-hand limit. And I would say that's equal to negative infinity, right? They just keep decreasing. And this right here, I would say, is the right-hand limit. And it looks like they just keep increasing, so that'd be infinity. So on one side, we're approaching negative infinity. On the other side, we're approaching infinity. So the limit does not exist because you're pointing to two different numbers. So the solution here, or the answer I should say, is does not exist. This limit does not exist. Now, what does this graph look like? Well, at 1, I would have a vertical asymptote. Coming from the left, my left-hand limit, the graph goes to negative infinity. So without even putting this into my calculator, I know it's going to look something like this. Coming from the left, it goes to negative infinity. Coming from the right, it's going to approach positive infinity. So you can see those two arrows point to different values, so the limit does not exist because the limit has to be what number they both point to, and that number's got to be the same. Okay, our next example. Now, I know this video is getting a little bit long, so if you already kind of had the hang of this, you don't have to worry about these last two, but for those of you that might want a couple additional examples or maybe come back to it in a day or two, I'm just going to finish these last couple out. Okay, so example 4, f of x equals negative 4x squared plus 12x over x minus 3. And I want to find the limit of f of x as x approaches 3. Okay, so I'm going to put 3 right in the middle of the chart there. And then I'm going to subtract 1,000th. So this is going to be 2.999, 2.99, 2.9. This will be 3.001, 3.01, and 3.1. So again, you'd be putting this into Y1 in your calculator, going to your table, setting up your table, and I got these values here, negative 11.6, negative 11.96. I got a negative 12, even though it has a rounding error. This did not exist. This said negative 12, and then I had negative 12.04 and negative 12.4. So again, the way this kind of works, this would be my left-hand limit. What are those pointing to as I get closer and closer to an x value of 3? Well, that looks like negative 12. My right-hand limit, also pointing to a negative 12. So since these are both the same, you're pointing to the same number, and that is going to be your limit, negative 12. So again, graphically, this looks like a line. If you put this into your calculator, it looks like it's a line. But remember, when x is 3, y does not exist. So it's going to look sort of like so. It's going to have a hole in the function. The coordinates of this point here are going to be 3, negative 12. And if you notice, this is why the limit exists. Because coming from the left and from the right, you're pointing to that same value. You're pointing to the negative 12. Okay, one more real quick. All right, now if you notice, this one looks a little bit different. Now, since we're using our calculator, you don't need to combine this into a single fraction. You just need to notice here we're finding a limit as x approaches 0. So what I'm going to do is I'm going to put 0 in the middle of my table, and then this would be negative 0.001, negative 0.01, negative 0.1. Going in the positive direction, 0.001, 0.01, and 0.1. Okay, so the y values. I got negative 86, negative 896, negative 8996. Does not exist. 9004, 904, and 94. So again, the way I like to think of this, here's your left-hand limit. What's that approaching? Looks like it's approaching negative infinity, right? Because the numbers just keep decreasing, and they keep decreasing more rapidly. Coming from the right-hand side, looks like they keep increasing. So now if you compare, well, that's negative infinity, that's positive infinity. That's not the same number. So this limit does not exist. Graphically, what would this look like? Well, as x approaches 0, coming from the left, you're approaching negative infinity. Coming from the right, you're approaching positive infinity. So without even looking at the graph, I know it's going to do something like this. So that's why, again, the limit does not exist, because that's pointing to negative infinity, that's pointing to positive infinity. Those are different numbers, no limit. Okay, so that concludes this rather long lesson. Thanks for sticking with me. Please do homework 12.2, and as usual, reach out to me if you have any questions whatsoever. Thank you.